Alright, so I just wanted to showcase my Minecraft adder and show you the sort of things that I did to make it possible. So here is the actual display room. We can see all of the output values here, and we can actually flip our inputs here, and this button will run the program. Now it's quite slow, so it would be a while for you to see the outputs, but before I do that, I'm going to fly around and show you all of the different components. So we'll start with the most important, which is the actual logic. So this unit here does all of the adding. It is comprised of, let's see, 4 AND gates and 3 OR gates. I used a schematic that broke down a 3-input XOR gate, which I then knotted, and that gave us a lot of our inputs, and then I added some other things. So I'll show you how the adder works. Essentially, we have these 4 AND gates. This is the first one. Here's the second one, the third, and the fourth. And then they're knotted appropriately in different parts. So for example, these values are knotted, and these values are knotted, and then these values are knotted. Then we have an OR gate right here. So it takes the output of these 2 AND gates, and then if either of them are true, then we get a positive right here. And then on the bottom, same thing. These 2 AND gates are wired to this OR gate right here. So if it's true, then this block gets powered. And then both of those outputs are wired to this last OR gate. Same thing. If either are true, then we get a 1. So this, those 4 AND gates and 3 OR gates essentially make an XOR gate, which is exclusive OR, meaning if any of the values are, if only one of the values is 1, then we will get a 1. And I noticed that on a truth table for an adder, an XOR gate and the NOT of the XOR gate covers all of our options except for all zeros and all ones. So what I did was I knotted our output, and then to cover the all ones case, I wired the AND gate here to our output right here. And then I wired, for the all zeros, I wired an OR gate here. And then I knotted it, and then wired it to our NOT of our XOR gate right here. And so the NOT will cover the all zeros case, and the AND gate will cover the all ones case. And then the XOR gate itself does everything else. So for example, if I have only one value, then we should get just a 1. And then if I have 2, we should get a 1, 0. And then if I have 3, we should get a 1, 1. So here is our outputs. This is the second digit. It's also the carry digit, and this is the one that actually gets written. So this one is wired all the way underneath, and I'll explain that in a second. But our second digit is wired, let's see, it's wired down here and goes all the way back into the circuit. So the written digit goes all the way under, all the way to the other side here. And I'll explain this in a second after I explain the timers. So the timers, these huge banks of, what are these? Repeaters, essentially will read all of our inputs simultaneously, and then, well, not simultaneously, but our input 1 and 2 simultaneously, and then after a given length of time, it'll move on to the next one. So if you look here, we have, these are wired to the levers, and they will basically toggle on or off for if we have a value or not. So these 3 are on, and when the timer reaches it, it will give us our value, which is wired back into the adder. Same on the other side. If we get a value, then it's wired back into the adder. And so our timers, each one also serves a second purpose. So I'll explain this one first. The purpose of this timer is to capture our output properly. So when I was messing with the adder, if I added or removed digits, I noticed that it would scramble our output a little bit. So I timed it so that it would get the correct output every time. and only produce it for a certain length of time. So that's what this does here. Captures the carry bit, and then this side captures the written bit. And so on the other side, we have a series of AND gates. Essentially what this is saying is, as it is reading our first digit, it asks if the digit is correct and if we have a positive output. So remember that wires all the way back to our output. So if both are true, then we toggle a switch. Same on all of these. If both values are true, then we toggle a switch. So these switches represent our written values, and they will turn on with just an input. So it's like a T flip-flop, right? So once this receives any amount of power for any duration, it will switch on. And then I have this button here to just switch all of them on and off, which basically wipes the display. And so each of these are wired all the way back. You can see them wired all the way back into the back of the display right there. So I'll run some values so you can see what's going on, and then I'll show you the inside. So let's say we have, this value is good. We have 111 and 011. So we should get a 1 here, and then a 0 carry the 1, and then a 1 carry the 1. So 1, 1, 1, 0. So we run it, and you can see the timer's going, and now it has captured the value. It's captured the second value, and this timer you can see is keeping track of where the digits are and when to write them. And our adder is doing, you just saw the carry line light up, and I think it's done calculating, but yeah. So let's check inside and see if it's correct. I guess I did my math wrong. Yeah, 1101, that's correct. And so I'll show you, it's quite slow to watch, but I'll show you with different values. So let's just write all ones, but we alternate. So we run it, and we can see that the screen will reset to all zeros. So we get a 1, and we should get another 1. Yep. Very, very slowly working our way through all of the bits. Now, the reason I designed it like this is because I, in theory, could expand it to as many bits as I want, and the addition would be the same. So right now I just have 8 inputs, and if you notice I have 9 on the output. That's for carrying. Not super important, but might be at some point. So yeah, that's about it. I think I've explained everything. If you have any questions, just let me know. Shoot me a DM on Discord or something, or any suggestions. I mean, this thing is, oh my god, it's way bigger than I thought it would be. I'm not very good at compacting my stuff, or Redstone in general, really. This is kind of just more of a way of proving some logic gates, fleshing out some logic for an adder. But yeah, that's about it. Thanks.